operations of complex numbers. So just like algebra and surds, we can do all the normal operations we can do on those with complex numbers. So we're going to have a look just with a few examples. So we're going to look at adding 1 plus 3i with 2 plus 4i. So this is addition of complex numbers. And all we need to do here is just add the real parts together and the imaginary parts together. So 1 plus 2 is going to give us 3, and 3i plus 4i is going to give us 7i. What about subtraction? Well, subtraction is very similar to addition, so we're going to look at 3 plus 4i minus 7 plus 2i. Again, we're just going to subtract the real parts from each other and the imaginary parts from each other, so we get 3 minus 7 is minus 4, then 4i minus 2i is going to give us 2i. What about multiplication? Going to have 1 plus 3i, all multiplied by 4 plus 3i, and we just have to expand the brackets like we normally would and multiply all the terms with each other. So we're going to get 1 times 4, which is 4. 1 times 3i is just going to give us 3i. 3i times 4 is going to give us 12i. And 3i times 3i is going to give us 9i squared. Now, we define I as being the square root of -1, and if we square both sides, that means I squared equals -1. So we can go ahead and sub that in. So we have 3i plus 12i is going to give us 15i, plus 9 times I squared, which we know is -1. So we're going to have 4 minus 9, which is going to be -5, plus 15i. What about 1 plus 2i divided by 1 minus 3i? When we have division of complex numbers, we actually like to we can think about it just like surds, how in a surd we rationalize the denominator. So here we want to make the denominator purely real. And we do that by multiplying by its conjugate. So the conjugate of the denominator will be 1 plus 3i, and we need to multiply by the conjugate on itself, because we want to multiply by 1 because we don't want to change the expression. And we just multiply all of this out. And what do we get? We get, on the numerator, we get 1 times 1, which is 1. 1 times 3i, which is 3i. 2i times 1, which is 2i. And 2i times 3i, which is 6i squared. In the denominator, we get 1 times 1, which is 1. 1 times 3i, which is 3i. Minus 3i times 1, which is minus 3i. And minus 3i times 3i, which is minus 9i squared. We can tidy this up. So we're going to get 1 plus 3i plus 2i is 5i. Then we sub in minus 1 for I squared. So we're going to get minus 6 over the 3i and the minus 3i will cancel over 1. And we again sub in minus 1 for I squared. So we're actually going to get plus 9 here. Let's tidy this up again. So we get 1 minus 6, which is minus 5, plus 5i over 1 plus 9, which is 10. And we can rewrite this if we take each term and divide them individually by 10. So we get minus 5 on 10 plus 5 on 10i. And we can just simplify the 5 on 10s to get minus a half plus a half I. And this would be the division of these two complex numbers. Now, when we did this division, we spoke about multiplying by its conjugate. So we're just going to look at some notation. So if we have a real number z that equaled x plus iy, its conjugate we actually represent with z bar, and all we have to do is change the sign. So if it's a plus, we change it to a minus. Or if it was a minus, we'd change it to a plus. And looking at conjugates, we actually can get a couple of results. We can get, if you multiply multiple conjugate complex numbers together, it's the same thing as multiplying all of the numbers together first and then taking the conjugate of that result. If you divide two conjugate complex numbers, that's the same thing as dividing the numbers first and then taking the conjugate of those numbers. And if you multiply a number by its conjugate, all you get is the real part squared plus the imaginary part squared. And you end up with a perfectly real number, as we saw when we multiplied this complex number by its conjugate. We ended up with a purely real number.